Hi, welcome back. Thanks for joining me. So this is continuing in our Chapter 8 packet. And so far, just to recap, in 8.1, we were just simplifying the rational expressions. In 8.2, we learned how to multiply and divide. So the multiply was just straight across the top, straight across the bottom. We were removing a factor of 1 to reduce it. Dividing, we did keep, change, flip, where we kept the first thing, changed the sign, and flipped the second fraction. Now today we are looking at adding fractions. So before we get into the polynomials, let's just go ahead and do just a basic fraction review. Okay, so when we're adding fractions, we want to make sure that we have the same common denominator. So in this first one, do we have a common denominator? We do, that's 7. So once we have a common denominator, then we just add straight across the top. So 5 plus 3, we get 8. And the second one, we have a common denominator of 34. And we'll just subtract 20 minus 11 is 9. Now in this next one, we do not have a common denominator. So what we have to do is we look at the factors of each of our denominators and we see what is the opposite fraction, what is the other one missing, what factors. Okay, so off to the side, I'm going to go ahead and factor 4. So 4, it's really just 2 times 2. 10 is 2 times 5. They share this common factor of 2. So 1/4, we look at the opposite one. Okay, so we have the 4, we look at the 10, and we say, well, which factor is it missing? Okay, so we look at the 4, we go to the other fraction, and we see what factor is it missing, which is a 5. So I'm going to stick a 5 right here. Now we can't just multiply just the bottom by 5. That wouldn't make any sense. What we can do is multiply a fraction by 1, right? Because we're just scaling it up. So instead of thinking of it as a 5, let's think of it as 5 over 5, which is just 1. That's going to help us scale that fraction up. For the second one, we have the 10. We go and we look at the opposite one, okay, which is the 4. We see what factor is it missing. It's missing the 2. So we multiply by 2 over 2. Now for that first piece, we have 1 times 5 is 5, over 4 times 5 is 20. Then we have 3 times 2 is 6, over 10 times 2 is 20. Now we have that common denominator. So we can go ahead and add straight across. We get 11 over 20. It might look kind of weird doing it this way, but this is what's happening when you're trying to find that lowest common denominator when you're normally adding and subtracting fractions. We're just doing it this long way because once it's polynomials, it's a lot harder to see what that lowest common denominator would be. So we find what factor they have that's the same, and then we find the factor that it's missing to find the lowest common one. So instead of just multiplying them together, like a lot of people, they'll say, oh, let's just multiply 4 times 10, so you get 40. So it'd be a huge fraction that they didn't have to reduce, which in this specific problem wouldn't really be too bad. But once we get to actual polynomials, that would be a lot more work to have to factor. Okay, so for this next one, you go ahead and try it. Okay, start by listing the factors of 9, the factors of 27, and see if you can do it this way. Go ahead and hit play when you're ready. So the factors of 9, we have 3 times 3. 27, a lot of you might have just said 3 times 9, but we want those prime factors, so we want it broken down totally. And if you don't quite see, just right off hand there, that is 3 times 3 times 3, something you could do is make a little factoring tree off to the side. So you might see 27, break it into 2 branches. You'd see that's 3 times 9. 3 is prime, so we know that branch is done. Breaking apart the 9 would be a 3 times 3, and then finally those are prime. So we would see that then our factors are 3 times 3 times 3. Okay, so we'll start with the 9. So we're looking at the 2/9. We're trying to find that lowest common denominator. So we go to the opposite fraction. We see, what do they have in common already? They have 3 and 3, right? So they have 3 times 3 in common. So we look for what is that first one, what is that 9 missing? So we go to the 27, we look and we see that it is a 3. We can't just randomly multiply by 3, but we can randomly multiply by 1. So we're going to go 3 over 3. Now we look at the second one, 27. We go to the opposite one, which is 9. We look and we see what is it missing. It's not missing anything. Okay, so that's why we don't have to multiply that one by anything. So in here we have 2 times 3 is 6. Over 9 times 3, we get that 27. Minus that 1 over 27, we don't have to do anything with it. 6 minus 1 is 5 over that common denominator of 27. Okay, so this part here is just summarizing the sum of two rational expressions. So it's just saying once you have that common denominator, you can combine the numerator, the top part. And then the difference, that just means subtraction, means if you have that common denominator, you can just subtract. And then just briefly what we're going to do is number one, we're going to make sure their denominators are the same. We're going to introduce those missing factors to make those equivalent expressions, which is just how we were kind of scaling up those fractions. Then we're going to combine the numerators and finally simplify. Okay, so let's go ahead and try some of these. Number one, 7 over 12x plus 5 over 8x cubed. So do you see how this one's a little bit harder to try to come up with that lowest common denominator? Okay, so off to the side, I just like to write factor and then put both of my numerators. Okay, so 12x. Okay, if you can see it already, you can just write down those prime factors. If you need to make a little factoring tree, that's totally fine. Okay, so the 12 would be broken down. You could actually break it down a couple different ways, right? 3 times 4 is one of them. We would have 3 as prime. 4 is 2 times 2. And then finally we have those prime numbers. I like to write them in order from lowest to greatest. Okay, from least to greatest. So 2 times 2 times 3. If some of you saw instead 2 times 6, do you think you would get the same thing? Watch this. You'd have 2 as your prime. 6 would break apart to 2 times 3. So even if you went that route, you would again get 2, 2, and 3. Okay, so 12x is 2 times 2 times 3. Don't forget that times x. Next, we have 8x cubed. And if you know already what the prime factors of 8 are, you can just write them down. If you need to jot off to the side a little factoring tree, that's totally fine. I'm going to go with 2 times 4. They can be broken down, the 4 to a 2 times 2. So the prime factors of 8x cubed are 2 times 2 times 2. And then x cubed is just x times x times x. So now what I do is I go through and I look and see what factors do they share in common, because I don't want to make this fraction enormous. I want it to be the lowest common denominator that I can get. So I'm going to circle what they already have in common, which is 2 and 2 and an x. Okay, now I'm going to go ahead and rewrite my original problem. I'm going to leave some space in between. So I'm going to put 7 over 12x times something. I don't know what that is quite yet. I'm just going to set it up for myself. 5 over 8x cubed. Okay, so now I'm starting with the 12x. So that means I go and I look at the opposite. I look at the other denominator, which is 8x cubed. I look and I see what factors is it missing. It's missing 2x, which is 2x squared. So I multiply by 2x squared over 2x squared. I go to my second one. It's 8x cubed. I go to the other fraction that I'm trying to get the common denominator, which is 12x. I see that it's missing the factor of just 3. So multiply by 3 over 3. Now, I can just multiply here. So I have 7 times 2x squared on the top is 14x squared. On the bottom, I have 12 times 2 is 24. X times x squared, remember we add our exponents and there's a little hidden 1, it's x cubed. Plus 5 times 3 is 15. Over 3 times 8 is 24, x cubed. And now you can see in doing all that work, we finally have common denominators. So now we can just add across the top, put it all over that common denominator. And what we would do next is try to see if we could factor anything. And if we could factor, we would go ahead and do that and see how we could simplify it, how we could reduce it. But in this case, there's nothing that we can factor out of that 14 and 15. So that problem is totally done. All right, cool. Let's see number 2. I'll help you get this one set up. This one looks a little bit different. Because of those denominators, let's go ahead and write it down here. So factor. Now, if you were to write x minus 4 totally factored, what would that be? See, this is why this one looks different, because there's nothing you can factor. It would just be x minus 4. Same thing with x plus 7, nothing to factor. Those just are two different terms, okay? So the way we're going to set this up, just like the other one, leave some space. Okay, and just like before, we have the x minus 4. We'll go the opposite one. They don't have any factors in common, right? Because this x, some people might say this x is what's in common. It's really not, right? Because that's only when you multiply. Because of this minus and this plus, that's not a factor. Because factor means that you've multiplied them together. Okay, so it's missing x minus 4. It's missing the entire x plus 7. So I'm put x plus 7 over x plus 7. The second one, we have x plus 7. We go to the other one, and we see it's missing that entire factor, that whole x minus 4 over x minus 4. Okay, so now, do we have a common denominator? Do you see that they would both just be x minus 4 times the quantity x plus 7? So let's go ahead and just make a giant fraction right now. X minus 4 times the quantity x plus 7. Now on the top, we have some work to do. We'd have 2 times that quantity x plus 7 plus 6 times that quantity x minus 4. Now you might be tempted to try to start canceling things out, right? Because you're seeing fractions on the top and fractions on the bottom. But remember, that's only if it's strictly multiply across the top. Since we have this adding sign, before we do anything, we're going to have to simplify it first, okay? So go ahead and take this 2, distribute, take this 6 and distribute. So first I want you to do that, then combine like terms, and then see if you can factor. Okay, so go ahead and hit pause and give it a try. Come back when you're ready. All right, so 2 times x, we have 2x, plus a 14, plus a 6x, minus 24. All over. The bottom is already factored, so don't go crazy and start multiplying that out. Okay, it's just x minus 4, x plus 7. Because that's not going to get you anywhere. Because later on, you're going to want to factor it, so you don't want to multiply it out now, just have to factor it later. So combining like terms, 2x and 6x, I get 8x. 14 minus 24, I get a minus 10. Still over that same denominator. And can I factor anything? Yeah, on the top I can pull out a 2. So I have 2, 4x minus 5 over the x minus 4, x plus 7. And that is our final answer. All right, how about this number 3? Go ahead and give it a try. Come back when you're ready. Okay, so we're going to factor off to the side. 6 and 2x minus 8. So 6 is 2 times 3. 2x minus 8, I can factor out a 2, and that would be times the quantity x minus 4. If you didn't quite get that far, go ahead and try to take it from here, okay? Hit pause and try it again. If you made it further, though, go ahead and keep watching. Common factor, that 2. I'm going to set my problem up with some space in between. So equals 5 over 6 times something plus 7 over 2x minus 8 times something. So my first one is 6, so I look at my other fraction, which is 2x minus 8 for the denominator. It's missing the factor x minus 4. I go to my second one, which is 2x minus 8. Look at the other one is 6. It's missing a factor of 3. Now, do I have common denominators? It might be a little bit harder to see this one. If we do have common denominators, okay, they end up being 6x minus 24. Let me show you why here off to the side. Because if I have 6 over x minus 4, I would have 6x minus 24. Now in the second one, I have 3 times 2x minus 8 distribute, I would again get 6x minus 24. So we get there different ways, but they are equivalent. Okay, so we do have common denominators of 6x minus 24. Now for the top, 5 times the quantity x minus 4 plus 7 times 3. Okay, so if you didn't make it this far, go ahead and hit pause and try to finish it off. And what you would do next is you would go ahead and distribute. So you would get 5x minus 20 plus 21 all over that 6x minus 24. Combine like terms, we'd have 5x plus 1. And on the bottom, let's go ahead and factor that. We could pull out a 6, and then we'd have left over x minus 4. That is our final answer. All right, next, number 4. We're going to try to get through just 6 of them today. Okay, so go ahead and try number 4, see how far you can get, and then hit play when you're ready. So to factor the first one, we have 2x minus 4. We can pull out a 2, leaving us with x minus 2. The second one is the difference of squares. So x squared minus 4 is x plus 2 times x minus 2. Let's circle what they have in common. Their common factor is this x minus 2. Let's rewrite the problem with some space. We're going to have x over, just to make it a little bit easier to see later on, you don't have to do this. I'm going to go ahead and just write the factored version as my denominator. That's just personal preference. Okay, so I'm going to put 2 x minus 2. It'll just help me see it a little bit easier, but you do not have to do that. Okay, plus that negative 4 over, again, difference of squares. Get a little bit of room there. There we go. So in this first one, we're looking at the 2x minus 4, which is the 2 times the quantity x minus 2. We look at the opposite one, which is the x squared minus 4, and we see that the factor that's missing is x plus 2. And the next one, we have the difference of squares. We look at the opposite one. We see that the factor that's missing is 2. Now our common denominator, they both have the 2, the x minus 2, and the x plus 2. Up on the top, we have x times the quantity x plus 2. And then instead of writing plus a negative, I'm just going to write minus, just so I have a little bit less to worry about. 4 times 2. Okay, if you haven't already, go ahead and distribute this x, combine like terms, and see if you can factor it further. So when we distribute, we get x squared plus 2x minus an 8 all over that common denominator. Okay, now can we factor that top part? Let's try it. A times c would be 1 times negative 8, so that's negative 8. B would be 2. So I need two numbers that multiply to negative 8 and add to 2, which are 4 and negative 2. Leading coefficient is 1, which means I can jump to the shortcut. Just fill in my numbers, so a plus 4, a minus 2. We'll rewrite the bottom here, and then we're going to see, is there anything that we can cancel out? So is there anything you see that's on the top and on the bottom? Since it's all multiply, we can go ahead and remove that factor of 1. So I'm seeing an x minus 2 on the top and on the bottom, leaving me with just x plus 4 up top. And on the bottom, we have that 2 and then the x plus 2. And it's really tempting to distribute that 2, but remember, we want our final answer just to be everything totally factored. So we are done. Let's try 2 more for today. Okay, so go ahead and try this number 5. Start by writing out your factors and hit play when you're ready. All right, so let's just go ahead and try to factor these. Let's see what happens. There's something a little bit different that happens with this one. X squared minus x minus 2. We want two numbers that multiply to -2 but add to -1, which are -2 and 1. So we can go ahead and set that up because we have our leading coefficient is 1, so we can jump to the shortcut. So we would have x, and again, two numbers that multiply to -2 but add to the -1. I'll get a -2 and a +1. In the second one, there's nothing to factor out. It's just x plus 1. But if you see, this is what's kind of different about this one. They do have that common factor of x plus 1. So in this first one, I'm going to write 2x over. Again, this is personal preference. I'm just going to go ahead and write in the factored version, just it's a little bit easier for me to see it. You could always factor it out later. It's nice though to just kind of get it over with up front. So if you're looking at this one and you see, I'm looking at the first one, I go to the second one, what factors is it missing? It's not missing anything, so I have to multiply that one by anybody. Okay, it's not missing a factor. So then I just have plus, whoops, let me erase that here. We're going to have plus, that second one is x plus 4 over x plus 1. So we're looking at the x plus 1. So we go to the other fraction and we look for what factor is it missing. It's missing that x minus 2. So we go ahead and multiply the top and the bottom by that x minus 2. So now we have our common denominator of x minus 2 times the quantity x plus 1. On the top, we just have 2x, and then we have plus this x plus 4 times the quantity x minus 2. We can't start canceling things out yet because of this plus sign right here. So what I want you to do now is to go ahead and FOIL out this second piece, combine like terms, see if you can factor. Okay, so I've just rewritten it with the common fraction here that we already figured out on the bottom. I have the 2x, and then if I go and FOIL that second piece, I have an x squared minus a 2x plus a 4x minus an 8. When I combine like terms, let's see, I just have the x squared. How many x's do I have? So I have this 2x minus a 2x, and I have 0 x's, but then I have plus 4x. So I have plus 4 x's. And then finally that minus 8. All over the quantity x minus 2 times the quantity x plus 1. So now we try to go ahead and factor the top. So we look at a times c. So that would be a, let's see, we have 1 and -8. So it'd be -8. And b is 4. So we try to find two numbers that multiply to -8, but add to 4. And after trying that for a while, you would see that that top part is prime. We can't factor it any further, so that is our final answer. We would leave it just like this. All right, just one more for today. Go ahead and try this number 6. Hit play when you're ready. Okay, so for number 6, let's go ahead and factor x plus y. We can't factor that one, so it really is just x plus y. The second one, though, we have 3x squared plus 4xy plus y squared. Leading coefficient is 1, so we have to break apart the middle term to give us the 4 terms. So I'm going to just show my work here off to the side. So I'm just going to bring down the 3x squared, bring down the y squared. Now I want two numbers that multiply to a times c, which is 3, but add to 4. So two numbers that multiply to 3, but add to 4. Let's try 3 and 1. So I'm going to break apart that middle term. Instead of writing 4xy, I'm going to rewrite it as 3xy plus, it's just xy, but if it helps you see it, you can write the 1xy. Now we have 4 terms, so we do factor by grouping. So the first 2, they have in common that 3x. So pull out that 3x, leaving me with x plus y. Second set, they have a y in common, so plus y, with that x plus y. They have the common factor of x plus y, leaving us with 3x plus y. So now we have the factored form, 3x squared plus 4xy plus y squared. So I'm just going to rewrite that up here. I'm going to circle any factors that they have in common. So they have this x plus y in common here. So in this first one, 3y over x plus y, we have the x plus y, so we go and we look at the other denominator, which is this guy here. We see what factors isn't missing. It's missing that factor of the 3x plus y. So I'm going to multiply this by 3x plus y over 3x plus y. And then I have my plus negative 9xy. Now is this other denominator, remember we go to the opposite one, is it missing any factors? It's not, so we don't have to do anything with that one. But just to keep it clean, let's go ahead and write down the factored version. So x plus y over 3x plus y. So now we have that common denominator of x plus y times 3x plus y. And up on the top, we'll have that 3y times the 3x plus y. Again, writing plus a negative, you can just write minus 9xy. Okay, so if you didn't get this far already, go ahead and hit pause and try to finish it off. So remember, you're going to distribute this 3y. You're going to combine like terms and see if you can factor. Okay, go ahead and hit play when you're ready. So 3y times 3x, we're going to get a 9xy plus a 3y squared minus a 9xy all over that denominator. Combine like terms, I have a 9xy minus a 9xy, leaving me with just 3y squared on the bottom. And there's nothing that I can cancel out, so that is our final answer. All right, so tomorrow it's going to look a lot the same. It's just going to be subtracting, and there's just one tiny little thing that's different. So that will wrap up today. Good job. I'll see you tomorrow.